Alrighty. All right. So in the last video, we talked about some simple rationalization. So we said that you've got to know what the problem is. The problem is the I in the denominator, right? So we don't want to have any I in the denominator, and you do whatever it takes so that you don't have the I or any kind of square root in the denominator. So make sure that you're not distracted. Make sure you know the reason why you do all those steps. Now, for this video, we'll focus on question 5, 6, and 7. And before we start, I'm just going to go ahead and remind everybody that we knew something. Okay, what's a plus b times a minus b? Remember this? What is a plus b times a minus b? Okay, everybody would say a squared minus b squared. Okay, a squared minus b squared. And so, okay, and why would I remind you? Because it's going to be very useful. Okay, I think we talked about this earlier, right? So we'll come back to this. All right. So, as we said in the previous, I think 2 videos ago, we were looking at this, right? We were rationalizing it. So we say, hey, how do you rationalize this? You cannot just do I over I because when you distribute, I mean, you get I square when you do I times I, but then you would have a 2I. So that would still mean you have an I in the denominator, and that's not good. So we need something better, and that's why we talked about a plus b times a minus b. That gives you a squared minus b squared. The conjugate, okay? Conjugate of a plus b is a minus b, vice versa. So we say, oh, what are we multiplying here? The conjugate of 2 minus I, it's 2 plus I. Okay, that's a conjugate. And why do we entertain the idea of conjugate? It's because in the denominator, we'll have a square minus b square. What's the a term? 2. What's the b term? I. For the numerator, it's just this, right? Nothing complicated. Just go ahead and multiply them. So what do we have in the denominator? We have 4 minus I squared, which is -1. In the numerator, we have, well, 3 times 2 is 6, and then 3 times I is 3I, so we have that. And so we have 6 plus 3I over 4 plus 1, and that's how you have 6 plus 3I over 5. Okay? Well, that's nothing you can simplify anymore. This is a constant. This is an imaginary number. They are not like terms. You cannot combine them. So that's it. That is our final answer. So for this example, from this example, we can see how we handle or rationalization when you have an addition or subtraction of a binomial and like 2 terms, adding and subtracting. So a plus b times a minus b is always the way to go. Okay, like I said in the previous video, this application of a plus b, a minus b taught me that it's not just about factoring. It's about the other way. How we can use it as a tool to get us out of a very difficult situation, such as having a square root in the denominator. Okay, and then what about number 6? We say, oh, for number 6, it's very straightforward. For number 6, it's simply multiplying by the conjugate of, okay, of 2 plus I, which is 2 minus I. The conjugate of 2 plus I is 2 minus I. Again, the numerator has an I in it, and we are perfectly okay. The problem is the denominator. So we work on the denominator and denominator only. So a plus b, a minus b, when they multiply together, that gives you a squared minus b squared. What's a? It's 2. What's b? It's your I. And then the numerator, though, you have 3 minus 7i times 2 minus I. So this is where the complication comes in. It's in the numerator because now you have to do a little bit more. which is you have to do FOIL. So first times the first, and then the outside, the inside, and then the last. Okay. So we say, all right, what's the first? The first, it's going to be 3 times 2, so you've got 6. Okay. And then you have the outside, which is 3 times negative I. And then you have the inside, which is minus 14I. And then plus 7I squared. And then here you got the 4. And then I squared is minus 1. We have seen it too many times now, I hope. And then 4 minus negative 1, it's 4 plus 1, which is 5. Now for the numerator, the 6 is still the 6. There's no like terms to combine. Now these two are like terms, okay? Minus 3i minus 14i, it's minus 17i. And then 7 times I squared is negative 1. So now, all of a sudden, we have a new constant term that popped out. So and because of this, we're like, 6 minus 7. What's 6 minus 7? Negative 1. So negative 1 minus 17i over 5. Okay? Negative 1 minus 17i over 5. Now, some of you might be thinking, hey, Mr. Chan, can I write negative 17i minus 1 instead of minus 1 minus 17i? Like, is the reverse of order in the numerator okay? Well, in terms of values, it wouldn't change much. However, when we deal with complex numbers, we tend to do a plus bi, this kind of format. So we put the I term last. So we put a constant up front. We put the I term last. So therefore, we tend to have the number up front. So it will be negative 1 minus 17i over 5. Some people might even go one step further and do this. Minus 1 over 5 minus 17i over 5. That works too, okay? Because they want to be very clear about what's the A term, what's the B term in the A plus BI form. So I'm going to take either one, okay? I'm going to take either one. So, all right. And then for number 7, all right, for number 7, again, what gives you the trouble? What gives you the trouble is the 5 minus 2i. So you do the conjugate of 5 minus 2i, which is 5 plus 2i. So we do this, all right, on top and the bottom. So in the bottom, we have a square minus b square. The a term is 5, the b term is 2i right there. And then you have 7 minus I, and then 5 plus 2i. So just like the previous problem, okay, we have the, let's take care of the denominator first. So we have this right here, and the numerator, you have to do the FOIL thing in the top. So 7 times 5, it's 35. And then 7 times 2i, it's plus 14i. And then negative I times 5, it's minus 5i. And then minus 2i squared. So just properly doing FOIL. And then we combine like terms in the numerator because we do have like terms in the numerator. And that would give us plus 11i. And then we see the I square right here that it's minus 1. Same thing with the denominator. We saw I square. So what does it mean? It means that we have 35 plus 11i plus 2 over 25 plus 4. So your final answer is 35 plus 2 is 37 plus 11i over a total of 29. Nothing we can cancel or simplify, and that's why it will be the answer at the end. Okay. Now, I wouldn't say it's easy. Okay. I wouldn't say it's easy, but I wouldn't say it's hard. It's hard either. Again, you have to make sure that your eyes are on the prize. or on the trouble. The trouble is a denominator that it has an I. So we learned only a couple of things today. Okay, really just a couple of things is to tackle the situation where you have a little I in a denominator. Whether it's a simple I like this, okay, like this, or you have a little adding or subtracting of an I term. What would you do accordingly when you see situations like this? Okay, so in both cases, we are simply multiplying by 1, but the 1, it's going to look a little bit different each time. Okay, so for the next and final video, we will go through some simplification of fractions because that it's really what we are going to see a whole lot after we learn this. So next topic, when we talk about quadratic formula, we're gonna see a lot of this, and we need to be ready for the challenge. Okay, so we are prepping ourselves for something even more advanced. Okay, so let's go ahead and watch the next video.